All right, we're out here on this Lexus. I don't even remember what model it is, but this is a YF vehicle, and it takes 550 grams. It looks like the engine label is missing on here. So we're gonna recharge this, but right now, this is one of those Toyotas with the plastic clip that breaks and often installed incorrectly. So if we follow this liquid line, you see the smaller of the two lines. If we follow this liquid line and we go all the way down, if we can see it, it goes way down there, somewhere right. See if I can get the light in there for you. Now, I got the light there, but will it focus down there? Okay, can I see it? Well, I'm trying to get it to focus, and right where you see that silver line and you could barely see the black plastic clip sticking out, that is the clip that breaks all the time. That is the clip that is often installed incorrectly, and they pop out after they get recharged. And sometimes under low pressure, when it's cool out and the high side pressure never gets up high enough, that clip will not pop out because it's in at a little bit of an angle because the line got twisted. It has some friction pressure because of the way the line is installed. So even after you charge it up and you run it, if the high side doesn't go up high enough, there's no vibration yet from the compressor, heat expansion of the aluminum, what happens is the customer goes out a day later, a week later, a month later, the clip blows out because it wasn't installed correctly in the first place, or it's an aftermarket condenser. I've been coming across where they'll save money on the condenser and then they'll go to Toyota and they'll order the plastic clip. But because of the machining, the stamp out of the the metal part in the condenser, the aftermarket condenser, it's not quite machined exactly like the OEM. So when the clip goes in, it doesn't have that shoulder to bite on, that little square edge to come back and clip on. And what I'm finding out through, you know, pressure, expansion and contraction, and vibration, the harmonic set up by pulsating refrigerant, after time, it blows out. So if you think you're going to save money on an aftermarket condenser and then buy the OEM clip, you say, oh, I have the answer to that. Sometimes some of the manufacturers on the aftermarket condensers have a poor casting or a poor machining. Their manufacturing of the retention for the clip is bad. So this is what I do. Okay, so right now you can see I have it under a vacuum. It's at 334 microns. It won't leak. You could remove the plastic clip altogether, not even have the plastic clip on, and it will not leak under vacuum because you're pulling in under vacuum and you have an O-ring. So we're going to add pressure to it with the nitrogen. So let me show you. I'm going to set the pressure. Actually, I dropped my gauges so both were broken. Have it backed out all the way. I'm going to show you something here. So let's set our pressure. I'm going to go up to, say, 175, 200 psi. So you've seen the vacuum, the micron gauge drop really fast. Look, we're down to 70, down to 64, 50 microns. That's because I just disengaged the hoses from the system, and now I'm only pulling vacuum onto hoses only. But we're going to set the nitrogen pressure. So let's close off the vacuum. Now the vacuum is closed, and you will see the vacuum go up because this is just by the permeation and contaminants in the hoses themselves, because refrigerant hoses were never designed for deep vacuum. So we have the nitrogen on, the regulator's off. You see it's broken, but I'm going to use this as my regulator. So what I'm going to do is I'm going to turn this in, and then all of a sudden, well, it would help if I open this. And then I'm going to turn the regulator up, and you see it's at 61 psi. Did I lose all my nitrogen? That's open, that's open. Ah, there we go. Took a little while. 170 psi. 172. So I have my regulator in. It's at 172 psi in these hoses up to this point. I don't have these screwed in. So now I'm going to screw these in, and we're going to watch the pressure go up. So now the pressure is going up in the system. It's going down right here right now because it just went into a vacuum. And so I'm waiting for it to come back up. Let's plug in the other side. Let me show you the other side. Let's see if this is a hard shut-off expansion valve. Will show a difference. Let me put that in. And you see the low side is only at 74. The high side's at 160 because that's a hard shut-off expansion valve. It only, even though I'm filling this up with 170 psi, the expansion valve will not let all the refrigerant through because there's a spring, there's a pintle, and there's a diaphragm on top that controls the level. It's trying to keep a differential, and that's what it's performing. So let's open up the low side just for the hell of it. You're only testing the high side. You don't need to do this. If you were doing an evaporator tester, you would want you would do that, looking for leaks. But under this situation, we only want the high side because it's only the high side line. So I try to jiggle the line. I can't get my hand down there and move it. They already have it all together. So there's no way for me to do a physical test because that line down there, and I can't even see it with this light, and I move my, oh, there we go. That line down there is, I'm unable to get it with my hands. And because I cannot physically do a physical check on it, there's no way for me to guarantee 100% it was installed correctly. I don't know if this is an aftermarket condenser on this one or not. So that's their problem, not my problem. If somebody chooses to use an aftermarket condenser in these scenarios or reuse the clip and it leaks, not my problem. That's your problem. It's going to cost you another $500 for me to come back to recharge it again because this is YF refrigerant. And you either do it once, do it right, and have quality parts like OEM Denso, or you half-ass it and you go get aftermarket condensers and then whine and cry that, oh, it leaked out, it blew out. Oh man, don't charge me a second time for it. That costs a lot of money. Not my problem, dude. You're the one who chooses to be cheap. It's a choice. Being cheap and being ignorant is a choice. All right? Got to get that clear right off the bat. All right, so now we got it up, say 170 psi, and it's not blowing off. So now turn off the nitrogen, have the high side close. I like to do a bleed through from high to low, out, disconnect. We're gonna just bleed off the nitrogen because that's what we breathe, nitrogen and oxygen. And so now it's bleeding out the end down there. You can see the pressure lower. And you can see that the pressure is being held back by the tiny orifice in the expansion valve. That's why it's so much higher on the high side than the lower where I'm bleeding it out at. And then I could open the vacuum and start the vacuum process all over again. Okay, so here we go again. We're gonna open up the vacuum and now we're vacuum. So this does not mean that that clip will not blow out after I charge it up, because once the condenser gets hot and the aluminum expands and there's a vibration and pulsation, the harmonics set up by the compressor pistons, and any vibration, if the clip is not installed correctly, it'll blow out after you charge it up. And that's not your fault. If you cannot get down there and somebody didn't correctly put it in, they use an aftermarket condenser, they didn't physically correctly check it, that's not your fault as the one recharging it. That falls back on the person who made the decision to buy an aftermarket part, or who installed it, or decided they were going to try to reuse that very fragile plastic clip. They leak all the time. All right, we'll get back to this when it's time to recharge it. See you guys later.